distracting. So we're doing 2 WIS talks today. I have the pleasure of having discovered that Anil has joined us in the Department of Performing Arts Technology. He comes from UIC, from the Electronic Visualization Lab, and I'm not sure necessarily where before that, but...
I was back in Istanbul.
Oh, okay.
Yeah, Istanbul Technical University.
Cool. So he's going to give us a WIS practice talk, and then we're going to break for getting shirts, if you don't have one yet, and then Sang is going to do a WIS practice talk after that. So take it away.
Thanks, man. Yeah, so I'm Anil Çamcı. I'm a new assistant professor at the Department of Performing Arts Technology in North Campus. So today I have the pleasure to tell you a bit about INVISO, which is a cross-platform user interface for creating virtual sonic environments, and I'll get into what that means. But before doing that, I'd like to show you the current state of the art in spatial audio interfaces. So this is Ableton Live, which is a hugely popular digital audio workstation, where producers used to create music with. So you're seeing a track view of Ableton Live, and on that top right corner there, you see a panning knob. Basically, it's a 2-dimensional slider where you can pan either fully left or fully right, and that conforms to our general understanding what stereo audio is, right? I mean, when we listen to music, things come from either left, right, or somewhere in between. So you can see that it's not a very important aspect of this UI as it is. And then you can also add automations to that parameter, so you can make sounds move gradually over time. But again, you can see that it's not very specific to define spatial audio, so you can just move it from left to right. And that's basically all we need in music production. But spatial audio has a lot more to offer. And there are actually interfaces for that as well. A lot of people work with surround sound. And there are plugins that you can add into Ableton Live to extend the interface of that software. So here, you're seeing this point, which represents sort of a stationary user in the middle of your system, whether it might be speakers or also it might be headphones. And then you have these sound sources that you can move around that stationary listener. And that tells a lot about what the intentions of this UI are. So it's definitely intended for home entertainment, or people listening to music through their headphones, and they're assumed to be sitting. But a lot of our experiences with daily sonic environments, soundscapes around us, has to do not only with the sounds moving around us, but also our motion in relation to those sounds. So that's how we navigate through our daily environments. And so there's I guess we could define a need to address that in a platform. And there are indeed environments that allow for the design of navigable sonic environments. So for instance, this is Unity. In Unity, you can drop in an empty game object in your scene, just like any other object you would drop in, and you can add an audio asset to that object, which could have a file, an audio file attached to it, and then you can sort of control these various parameters. That is somewhat limiting in a couple of ways. One is that's the interface for dealing with the visual objects in this environment. So audio doesn't get its own set of tools inside Unity. Obviously, this is catered for mainly for creating 3D visual environments. And then on the other hand, whatever features they have for audio adheres to those visual design UI paradigm. And then again, those parameters are a little daunting for a novice user. So to address some of those limitations and to propose new applications, we've designed INVISO, which I'll get to what it looks like in a minute. You have a brief sort of sneak peek behind here. So this is a browser-based application. It runs on very standard web APIs like WebAudio, WebGL using 3JS, all the UI is CSS. So it basically runs on all the browsers that we tried it with. And it allows you to design navigable sonic virtual environments, and we'll just do a demo of it in a minute. But I guess more specifically, this UI allows the rapid design of sonic environments displayed in the form of a 3D virtual scene with objects that are spatialized for audio that you can manipulate in 3D space. And it offers both an interactive mode where you can just use very standard point, click, and drag interactions, but it also has these inspector views where you can have parametric control over those interactions. So when I started designing this environment, one of the places that I drew inspiration from was casual creativity tools for visual design. So, in my childhood, I played around a lot with Microsoft Paint, which led to Photoshop, which led to web design, and then I actually spent my high school years designing websites for a company. So that casual creativity has led to something more professional over time. And we do have some, I guess, creativity support tool that's casual in the same manner in the music domain, where you have things like music memos in your telephone, where you can create multiple tracks of an audio, musical piece. But you don't have that for spatial audio, again, which is a huge part of our experience, and it's becoming more and more important as new virtual reality technologies are introduced. So by introducing this twofold approach to interaction in this application, we try to address both novice users who might want to be, casually designing spatial environments, but also using those parametric interactions. You can sort of cater towards more professional users who work with spatial audio. Usually directionality in game audio, like you saw in Unity, is achieved with what we refer to as sound cones. I'll get to what directional audio means, but you can think of it as just like a horn that gives sound a directionality. So as you're walking inside a game, if a character is talking over there, unless you get close to that character, you don't hear him or her clearly. And that's achieved through these virtual cones that give directionality to audio. But that's a fairly rudimentary implementation of what directional audio in real life is. So to address that, we've implemented a sound object that can have multiple cones. And you can add dynamism to these objects with hand-drawn trajectories because moving sound sources contribute to the articulation of space in such virtual environments. And with something like Unity, you often have a mode where you design the environment and a mode where you can actually play it back or render it. Due to, you need to bake that lighting in that scene, it takes some resources, you cannot do all that in one mode. But with audio, our current technology came to the point that we don't need to make that differentiation. So with INVISO, you don't have that separation. Whatever you design immediately comes up in that scene and it's immediately rendered. So that opens up a lot of possibilities. Users can go into those virtual environments and design them as they experience it. And since this is cross-platform, it can run on your tablets or phones, so it opens up a lot of augmented reality applications that I'll get to in future work. So before doing a demo, I'd like to talk about how we started working with INVISO, the design of INVISO. We first began to conceptualize a visual taxonomy of spatial audio. So we looked at soundscape theory, how we define our daily soundscapes. So we started with directional sounds. So for instance, I'm a directional sound source. My vocal tract acts like a waveguide so that my voice is sort of directed to you right now. And if I were to do the speech, turn it this way, you would have different time of arrivals, different levels of arrivals, that would contribute to your understanding of where I'm standing, where I'm looking at. And like I said, that's usually achieved with cones, but then you also have omnidirectional sound. So if I were to clap my hand in an open air environment, it would dissipate in all directions. It wouldn't necessarily be passed through a waveguide. So you have these sound sources that just propagate in all directions. And we represent those with spheres. And then you have non-directional sounds like it might be an AC noise, it might be traffic noise, sounds that you cannot quite tell where it's coming from, but it's still there. You can think of ambient noises as non-directional sounds, and we represent those with simply connected regions. So as we designed INVISO, we started from this conceptualization of what a soundscape is in a visual sense, and then we tried to implement them in this environment, looking at how we can start from a complexity of features and how we can sort of simplify them in a way that it can cater to both novice and experienced users. So that is a model of a sound object that you see on the left, and on the right you're seeing two overlapping sound zones, and all of these contribute to what we refer to as a sound field. So before going any further, I'll do a brief demo of what INVISO looks like in action. Yeah, we should bring that up. So this is Safari. It's just in full screen mode. So when you start INVISO, it's a fairly simplified view. So like I said, when we started designing it, we've had all these like UI elements and object types. So it was sort of a really crammed UI, and a lot of the research went into looking at how we can group those things and how we can simplify things and how we can extract things that are not necessary, how we can sort of put the focus of the UI on things that are really important in designing these sonic virtual environments. So it starts with 3 cues as to what you can do with INVISO, and that stands out as sort of a welcoming point to that interface. So once you press the plus button here, you can either click and create a sound object, or you can click and drag and draw a sound zone. And the difference between those two, as I mentioned, is whether they're directional or not. So let's assign a sound file to this sound object. This could be any file, but I'll just pick this. Okay, so one thing I need to point out is that the left-right is going to be flipped right now. So when I move the sound source to the left of the dummy head here, you're going to be hearing from this channel. But when you do it with headphones, it's the right where I want. So I guess when I said navigable, what I meant was that you can move your listening head in this environment in relation to these sound sources. And we can change the loudness of that sound object. And that still retains that directionality. And that's omnidirectional. I guess I can delete this for now. So that's omnidirectional. As I move this around the listener, this file that I attached to this object is propagating in all directions. So wherever I put it, you still hear it. It just gets spatialized around you. And let's talk about non-directional sound. So unidirectional sound. So I'm going to remove this omni element, and then I'll add a cone. And maybe let's do this one. So when you add a cone, it goes into this object edit mode, which allows you to design the sound object in detail. So I can change the spread of this. Again, increase the volume. I can add another cone with a different sound on it. So maybe let's try this beat here. I can actually also change around and look around this. I'll make that a little spread less. So it becomes really audible when you're in the zone of throw for that cone, but it's less so when you're out of that zone. So let's go back to that main view. So when I move this, object ground, obviously that directionality will be implemented. And I can actually add a trajectory to build that motion. And I can walk around this. I guess that's sort of an extra point. I can make this go faster or slower. And I can add an infinite number of objects into the scene. They can have an infinite number of, as long as your computer supports it, cones on them, so you can create these really complex sound objects. So that's directional sound with unidirectional characteristics. I guess one thing to point out is that everything I've been doing so far has been in 2D, but if we flip this screen into 3D view mode, I can move this object now in 3D, and I can actually make it move in 3 dimensions as well. Oh, I just caught the object there. Let's make that go a little faster. So let's talk about zones, sounds that are non-directional. So let's go back to aerial view, and I'll get to what the difference between aerial and altitude view in a minute. Let's add an object as a zone. Let's attach. So I can, that's what I mean with when you edit it, it's immediately rendered. I'll make that a little quiet, and I can actually walk into it. Let's add another one to demonstrate the overlap of these. You can still hear that directional sound going in the back too, and that's spatialized. I'm not going to add another object, but I add a file to this. So let's add that. You can now hear both of those sounds. So I could presumably draw this thing all around that scene and make it sort of an ambient component of the sound environment that I'm designing. And yeah, you can save these scenes, load them later. You can mute the whole scene, which stops all spatial information, so you can edit offline as well if you don't want any sound to be going on as you fiddle around with it. So those are the main features of INVISO. Let's go back to the presentation. Wait. Okay. So that was the demo. Some of the UI considerations that went into this. So I mentioned that there were two views, the aerial view and the altitude view. A study by Owen Sturzinger says that obviously dealing with 3D environments using 2D interaction is a very tricky problem to tackle. And their study from 2005 say that instead of using axis handles to move objects in 3D, using separate views with limited control creates a bit more efficiency. So they've done a study where users were a bit faster in designing the 3D environment they had in mind with split views that had limited degrees of freedom. So that's one of the reasons we went this sort of limited view where in the aerial view you can only move the sounds in the XZ domain, in the lateral domain. And if you sort of tilt that screen when this view flips to altitude view, you have control over only the Y axis. And like I said, that study was one inspiration, but it's also mainly because there's a unique disposition of the human spatial hearing, where we're really good at pinpointing sounds in this area at ear level in front of us, but we're not that good with sounds that are behind us or that are above or below us. That's why we get really confused when a plane is passing over by and we cannot tell where it's coming from. So imposing this limitation sort of puts the emphasis on those lateral interactions, so the users don't have to deal with the axis handles to put the sounds in where it's important in the lateral domain. And if they want to add some third dimensionality to their sounds, they can just switch into that altitude view to manipulate their objects. Dual mode UI, and again, I mean, you'll recall that when I wanted to add a cone, it went into this close-up view of the sound object where I could design the object itself individually. So we wanted to have both the platform to design the environment itself, but also the objects inside it. So with something like Unity, you would usually design your environments in a 3D design platform like Blender or 3D Max and then import them inside Unity. But with audio, we wanted to keep it simple, but at the same time give the opportunity for the users to design these really complex sound objects in that same continuous dual mode UI. And dynamic windows is basically, we have these inspector windows that pop up contextually and gives you parametric control over all the things you can control interactively. So I'll talk about a sort of a small explorator user study that we've done with INVISO. So here you can see on the y-axis we have the level of expertise with digital audio workstations, like Ableton that I showed in my first slide, so like music production software. And on the x-axis we have VR authoring tool experience level in like Unity. So we've had, for instance, 3 people who are experts with digital audio workstations but have no experience with VR authoring tools and so on and so forth. So they were given 2 tasks. The first task was an open-ended design prompt. They were given a 5-minute introduction on INVISO. So we've opened this page up and showed what each of these entry points were capable of doing. And after that 5-minute, they were told, okay, now you can design a soundscape and you'll just tell us when you're done. So we haven't given certain limitations or we haven't imposed constraints. And usually the users took roughly about 10 minutes to say that, okay, this is done. I guess the shortest was about 8 minutes and the longest was about 13 minutes. And the second task was a recreate task. So in this task, users were given 2 instances of INVISO in 2 different browser windows. And in the first instance, there was actually an environment designed in there, but you couldn't see the visual objects like you would see during the demo. But as they walked around the scene, they could actually hear them. So we wanted them to listen to this instance, walk around it, navigate around it, and then go to this empty instance and then try to recreate that environment using the tools available inside the application. So here are some user designs from the create task. And what's really interesting is that it's not a huge group. We've had 10 people, but all 10 of them had different creative approaches to this. Here we're seeing a user create a topographic map of sound zones. Another user created a bit of a map of islands of sound zones, so you could think of these as approaching it as maps. While this user focused on the complexity of spiraling sound trajectories that these objects would follow. And when asked, they described that their goal was to create rhythmic structures. So these trajectories were set to fast movement. So they were actually really fastly going around the user, creating these like rhythmic patterns around them. And there the user thought the ambient sound that we just heard sounded like a roller coaster when it's put into that particular trajectory. And actually went back and listened to it, and it does sound a bit like a roller coaster. And none of these users are experienced with digital audio workstations. They have no experience with digital audio workstations. So this is a really sort of an inspiring outcome of this first study. Here are some more results. This user decided to focus on the complexity of objects with a lot of cones. That user is experienced with audio spatialization tools, and maybe that's why that user kept his character in the middle of the scene and draw these trajectories around it, very much like that interface that we saw, the audio spatializer with the stationary user in the middle. So maybe that user's experience with these tools sort of impeded his ability to explore further capabilities of what this could do. Okay, and going on to the results of the recreate task. So this is the environment that I've designed. You have two overlapping zones. This is what I would use for demonstrating what INVISO can do. Two overlapping zones. One sound object that's omnidirectional, that's not moving. Another omnidirectional object that's moving on trajectory. And then a third object with two cones on it, so a bit more complex unidirectional object. Or I say bidirectional. So keeping this in mind, these are the recreations of the users. So they were asked to roughly recreate them. We didn't want them to spend hours and hours to figure out the exact point where that zone ended. So they would just quickly go to that instance where they had no objects but sounds coming in from this design here. And then go back to their instance of it and then just draw this around. So we wanted to see if they can recreate from memory or recreate from an existing environment. So we can see that most users got the sound zones, and in terms of the variety of the amount of sounds, almost everyone got them right. So you can see here, for instance, instead of having an object with two cones, this user thought the second cone here would be another omnidirectional object. This is usually correctly pointed out by all the users. And I guess you can sort of understand why some of those trajectories are loops. I mean, it's going back and forth, but it's not precise enough. Like in real life, we wouldn't be able to tell if a sound is going back and forth or doing a little loop. So some of the users have done loops instead of just a single line, spline curve. This is the only user who got the two-cone model. All of the users either did a combination of a single cone object and an omnidirectional object, or a combination of two omnidirectional objects. So that tells us about maybe our the algorithm that we use to determine the fall-off characteristics of a sound cone that we might need to revisit. But it also tells about a bit of a flexibility there, where a similar sonic phenomena can be defined in different ways. This is another set of user set of results. So here, even in this particular instance, the number of object matches, right? You have this omnidirectional sound, that one that moves on a trajectory, and then those two overlapping sound zones. But instead of having two cones projecting sounds, this user thought those were sound zones, right? And hence, they actually pretty much drew a cardioid pattern for the propagation of that sound, which is, again, really interesting. And again, that was the basic design. We did a qualitative feedback session as a follow-up to this study. They were asked survey questions in terms of the clarity and accessibility. So that's the blue bar of the features of the UI after a 5-minute presentation, and then having done the two tasks. The green bar is the complexity of creating and manipulating 3D sound objects with the UI, with short being complex and tall being straightforward. And yellow is the ease of realizing a spatial sound idea with the UI. So given a soundscape, how easy it was for them to recreate it with the UI, with short being hard and tall being easy. And then the correlation between visual objects and sounds, which has been one of the more highly commented aspects of it. So we did a brief interview after the survey as well, and they felt like the correlations between the visuals and the sounds were tightly coupled. Some applications. Obviously, casual creativity is really important for us. We want people to be able to sketch these spatial sound environments, and we don't think there's another tool that allows this at this scale. At the Electronic Visualization Lab, as we designed this, we've also envisioned this as a way to couple this with immersive visualizations that we do in the cave systems. So our backhand accepts OSC messages, so you can presumably map visual objects in an immersive visualization environment to these sound objects, and then actually make them sound behind you, which is really important because in an environment like cave, you might have salient information behind you, that you would actually need to turn back. So audio presents a good opportunity there to direct attention towards those salient points in your data. This can be used as a spatial sonification tool. We've had architects working with this to prototype sound environments, like actual sonic environments that they might be doing a design towards. And then, since again this accepts external data, this could be a plugin for Ableton Live or Unity to do a bit more advanced, but yet at the same time interactively easy implementation of spatial audio, which is something that we haven't experimented yet. And again, for me, as someone working both in the domain of engineering and arts, this is also a compositional tool that I can go and perform with. And some of the future work, comes from user requests. So one of the benefits of giving that open-ended design prompt was that a lot of people had to think about what they might want to do with that system, and at the end of it, that resulted in having them ideas as to what might improve our UI. And we've been proposed applications that we didn't think of. A composer said that you could use this system to apply for a grant. So a lot of composers do grant applications for sound installations, and it's really a weird thing to do, like to write about a sound installation and have it reviewed based on what you can write about it. So his suggestion was that you can create an environment, like a demo of your sound installation with this, and send a file that you can save with the interface, and the grant reviewers can just open their browser, load that file, and actually navigate that sound installation. Some of the users requested gradient zones that do not immediately start as you go in it, and that's something that we've been wanting to implement. It's just a bit tricky to implement with those open-ended simpler connecteds, so we're trying to figure out the best way to do it. And they wanted to add trajectories to sound zones. That's something we haven't thought. We thought that sound zones resembled ambient sources that just stayed there all the time and were just like omnipresent. But they wanted to make them move around, which is a reasonable request. And an object duplication is an obvious request that we're currently implementing. One thing you've noticed is that I've attached only audio files to these objects, but we're also thinking about, it's going to be an easy implementation, adding audio streams into these objects, so you can have something like a Skype conversation where you attach individual participants to these sound objects and put them in space. You can move them in space too, if you want to have fun. And then I referred to an augmented reality implementation. So what we're going to do next is to, since this can run on your tablet or phone, we're going to get the feed from your camera, and then you'll be able to put these sound objects in real time in augmented reality in the physical space that you're exploring. So instead of navigating the space virtually with that dummy head, you can actually walk around it with your phone or tablet. And again, since this is running on the browser, it's online, it's very open to multi-user collaboration, so we're implementing a way to invite multiple people into a single scene where they can add objects, manipulate them at the same time, and share that same environment. And that's about it. That's my email address. If you have any questions and comments, I'd be happy to hear them. And this will be presented later this month at WIST, hopefully a tighter version of this. But yeah, I'd be happy to take some questions right now. Thank you. Any questions, comments?
The goal here is top feedback prior to the conference, so everybody has their chance.
Yeah. And how much time do you have? Just because I know you have to run. So.
I can do another 5 minutes.
Okay.
So just to kick things off, yeah, like you said, I assume it's shorter for the conference, but I think the opening that you have right now certainly creates a lot of anticipation, right? But if you started off with like a video, a lot of WIST talks do this on the title slide, right in the background, of like what does it look like if this works?
Right.
And then leave that as magic while you go through how painful it is to do it with current technologies, right? And then maybe walk through the system itself instead of the bulleted list, right? With actual like short GIFs on each thing. There's a bit of a pecking order in WIS talks, right? It's like put as much video in it as you can.
Right.
If not video, then maybe some pictures, and then like last ditch effort is text. I've certainly seen talks that won awards that just did between 1 and 4 videos per slide and never had text on it. I don't think you have to go to no text personally,
Right.
but certainly like you have a really cool visual thing, and seeing more of that earlier on would be awesome.
Okay, thanks. I think I saw another hand. Raising? No? Go.
Alright, have you done this with like Google Paint, like some similar interface? Like?
You mean in virtual reality?
Yeah.
Not yet. I mean, we've experimented with plugging this into web VR and putting it onto a headset, but you don't have the interaction implemented, so it's just basically looking at a 3D scene.
Okay.
Yeah.
This is not a talk feedback, but have you talked to Michael Niebling?
No.
So he's doing like AR prototyping, not for sound.
Okay.
But there might be like interesting
Is that a UM professor?
collaboration there. Yeah, he's a professor in the School of Information.
Okay.
Um,
Taking a look at that.
yeah.
Thanks. Any other comments? I think I saw.
Well, I just want to make sure I understood the augmented reality application of it. Does that mean like based on where I'm standing in a room will affect what I hear, the directionality of what I hear?
Right. Yeah. So you would be able to basically go around the room and then place a sound object here, and then move here, place a sound object there. Your ears would have to be your Donnie head model would have to be the phone. So there might be a bit of a disjointedness there, right? If you were to put your phone there, obviously you would basically move your head there, so you would hear that spatialized accordingly. But if you keep the phone at head level, you would have a sort of a true rendering of the sound scene. And then you would be able to see those objects overlaid onto the video feed from your handheld device. But that's work in progress. Any other question or comments? Okay.
Thanks
for
for
listening.
again.